In today's video, we have another piece of vintage audio equipment that will be repurposed for guitar use. It is the vacuum tube portion of a Bell & Howell 614 16mm projector, produced for the US military in the 1960s. Built like a tank, note the ruggedized power and output transformers dipped in some sort of epoxy resin. At the top, behind this metal screen, we have the filter cap cans, as well as the tubes. To the left, we have both the volume and tone pot shafts extending into the chassis, along with the power switch. On the right side, from the top, we have a 1/4-inch input, a switch allowing you to select between the internal speaker or an external one, and below we have an XLR jack for a 16 ohm extension speaker. Let's flip it over and check out the front. It has a kind of brutally industrial look. Let's undo these screws and get a look under the hood. Mounted on the panel is a little 8 ohm Alnico speaker made by Jensen. On the left we have the turret board here with the audio circuit. Opposite the power transformer and the oscillator circuit, which was used to read the audio information from the film. Let's pop off the upper panel and check out the tubes. Two 12AX7s, the power tubes, a pair of 6 AQ5s, a 6x4 rectifier, along with another one behind it, so it's a dually. These two tubes look dead. The white tops indicate that they've lost their vacuum, and glancing over at the circuit board, we can see that the first resistor in the power rail is burnt to a crisp. Next in line we have our fuse holder, and mounted on the screen we have tube spares, a 12AX7, a 6x4, and a 6AQ5. Left one of the shields on. We have a 6AQ5 for the oscillator. We're going to begin by making some room, removing some components pertaining to the projector that we will no longer be needing. A 3-prong IEC socket will be installed in this gap, and the handle from the projector case will be mounted at the top. The feet from the projector case have been repurposed and installed in these pre-existing holes. Other modifications to the chassis include drilling a new hole under the speaker switch for a new 1/4-inch jack, removing the XLR jack, widening the hole in order to replace it with this 1/4-inch jack plate. So now the switch allows you to select between the 8 and 16 ohm external speaker jacks. A 50 watt 16 ohm resistor has been installed here. So now, when nothing is connected to the shorting jack in the 16 ohm position, we have a dummy load. And the internal speaker has been connected to the 8 ohm shorting jack, so when nothing is connected, it will drive the internal speaker. On the other side, we're going to make and install a panel filling this gap and allowing us to mount the hinges for a back cover. Looking over the schematic, we will go over the modifications we'll be making to the circuit. We have 3 gain stages in the preamp, feeding the cathodiene phase inverter that splits the signal for our push-pull output stage. You could think of it sort of like a Tweed Deluxe, but with an extra gain stage in the preamp. We have abnormally high plate and cathode resistors, setting the operating point for our 3 preamp stages near plate starvation, resulting in a rather sterile and compressed tone. So we will be replacing all of the plate and cathode resistors with standard Fender values of 100K for the plate and 1.5K for the cathode. This will give us a more dynamic and fuller sound. The input circuitry has been removed and replaced with a standard Fender style input circuit. We will be leaving the EQ section stock based around this 5-position switch. And because we reduced the value of the cathode resistor at the 3rd gain stage, where our negative feedback is injected from the output transformer, We will also be lowering the value of the series resistor to maintain the same amount of negative feedback as before. Looking at the datasheet for our 6AQ5 power tube, we can see that no more than 250 volts is recommended for the screens. On the schematic, they have 285 marked at the screens, so already they are pushing the value a wee bit above our design maximum. With the increase of modern wall voltage, our screen voltage will be raised even higher. To compensate, we will be modifying the power supply. Instead of our output transformer being connected here at the first node after rectification, we will move it over to the second node and replace this 350 ohm dropping resistor with a 100 ohm, reducing the B+ fed into the entire circuit to compensate for our elevated voltages, and replacing the dropping resistor to the screens in the second position to 4.7K, bringing down the screen voltage closer to our design maximum to prevent excessive wear and premature failure of our output tubes. The 6.3 volt heater winding was up to 7 volts when I performed a voltage check initially, so we will be adding this turret strip to mount a pair of high current diodes and anti-parallel on one side of the heater winding to bring it back down to 6.3 volts. Moving on to the electrolytics, under the turret board, we're going to remove the cathode bypass cap to the output tubes. Here's one of the original cap cans made by Sprague. They have an octal tube base, so they would just plug in right here. They are no longer in production, so we're going to use these replacements I made by soldering some radial caps in these empty octal tube bases. Shrink wrap the tops, and we can insert them like so. All of our components have been swapped out on the turret board, including these paper and oil coupling caps to the output tubes. Now that all the work is done converting this Bell & Howell 614, let's see how it sounds. First, here's a quick rundown of the tone control. In the middle position, labeled normal, the EQ is full range. To the left, we have low 1, which removes some high frequencies. Low 2 removes even more. And to the right of the center, we have high 1, which removes low frequencies. High 2 removes even more. For the sound demo, we're going to leave it in the normal position.